researchers! Get ready for a wild ride through the statistical jungle. Today is all about the Spearman's rank correlation coefficient. Picture this. We are unraveling the secrets of relationship without the boring math lecture. So, grab your curiosity and let's break down the Spearman's law like the DIY detectives of data we are. Let's go!
Spearman's law, named after Charles Spearman, is a non-parametric test used to measure the strength of association between two variables, where the value r equals 1 means a perfect positive correlation, and the value r equals -1 means a perfect negative correlation.
Rho equals 1 minus 6 times summation of d sub I squared over n times n squared minus 1. The test is used for either ordinal variables or for continuous data that has a field depth assumption necessary for conducting the person-product movement or correlation.
Our researchers want to investigate the relationship between the numbers of our students. Span is studying for exam scores. A sample of 10 students is selected. In their study hours, 8 exam scores are recorded. The data is as follows. To solve this problem, you will need to rank the study hours in exam scores separately for each student. Calculate the difference between the ranks of hours in exam scores for each student. Square these differences and calculate the sum of squared differences. Use the formula for Spearman rank correlation coefficient to find rho.
Now we have our formula. If we use this, we'll have 6. 6 is a constant, so we'll just write it down. D sub I squared is our difference, and we squared it and took the total, thus reaching 72. So this is 72. Divided by n is the number of cases, and we have 10. So 10 times 10 squared minus 1. 10 squared is equals to 100, minus 1 is 99. Continuing, we have 6 times 72, which is 432. And 10 times 99 is equals to 990. 432 divided by 990 is equals to 0.44 rho. Based on the scales shown below, we have a positive moderate correlation. But the question is it significant?
Now, this is where the second equation comes in, the t statistics. We'll use it to find out if the 0.44 that we got is significant. So, t equals, rho is 0.44 times the square root of n, which is 10 minus 2, divided by square root of 1 minus 44 squared. Now, if we solve it all we get is 1.39. Now, we'll compare this with the t critical. Because we use t-test, we must use the t distribution. We also got to have the alpha level, so for now, we'll get 0.05. And the degrees of freedom is n minus 2. So 10 minus 2 is 8. Now, looking at the t distribution, our degrees of freedom is 8. Our alpha level, we'll use two-tailed, for this is 0.05. And its equivalent is 8, so we have 2.306. This will be our t critical.